our staff for today. Welcome, hello and welcome to the second TMS Tuesday. For those that are joining us for the first time, my name is Robert Shapton and I'm Managing Director of TMS Training Solutions. And we're very proud to host these free airfield lighting webinars, which I hope you'll find both interesting and informative. In this second week, Keith will be covering airfield safety, runway incursions and how to prevent them. He'll be introducing you to the standards governing airfield lighting and also be talking about the design and layout of airfields, power supply systems and AGL circuits. But first, a lot has happened again since last week as we try and emerge from the current crisis. The Airports Council International has published a comprehensive document which we'll be putting on our website covering operations during COVID-19 and in particular the restart and recovery of aviation worldwide. They talk about the return of business in 4 phases. Concerning runways, aprons and taxiways in particular, the report is built up into sections. They talk about how we're going to have to operate often with less physical resources. Many of our systems will not have been used or will have been discontinued over recent weeks. We will have fewer personnel. Some of our electrical systems may be out of service, and some of the visual aids may no longer be working. So they then go and talk about what we've got to do about that. In relation again specifically to maintenance, airfield runways, aprons and taxiways, we've got to identify operational safety risks prior to restarting operations, take mitigating measures, obviously, and they recommend in particular we conduct all the preventative maintenance steps that we would have been used to have been performing since the shutdown or virtual shutdown of operations. EUROCONTROL again has also published a weekly update. We're talking about week 21 last week. They've identified that there were traffic was 85% down, which is a slight improvement on the previous week, roughly 178 flights per day. DHL Express is once again the busiest airline with 175 flight movements, and the busiest airports were Frankfurt with 255 flights, Heathrow 236 and Schiphol 214. So it's still a pretty grim for us all out there. I know a lot of you are working on airfield lighting maintenance and the preventative maintenance measures ready to restart operations. What I'd like to do now is to hand you over to Keith, our speaker for today's presentation. Keith is Director and Principal Trainer for TMS Training Solutions Limited. He has 50 years experience working in the airfield industry, airport industry, and is a renowned expert in the world of aviation and training. So without any further ado, if I can hand you over now to Keith, we'll just hand over control of the presentation.
Hello, Robert. Yeah, you've got to, allow me to come in and.
Right. Okay. There. So if I can just allow you to do that, just one moment, please. Okay, Keith. I think you're ready to go.
Okay, I'm going to continue. So what we'll do here is starting on from the elements associated with what Robert.
I've lost you there, Keith. Are you there still?
You all got me? Hello?
Yes, okay, got it.
Hello?
Yes, we can hear you.
Yes, okay. So let's move on. And, this is webinar 2, as Robert has said. last week we had we discussed a lot about the regulatory issues and the return from COVID-19. This week I want to get into the engineering side, and but on the engineering side, our systems must be safe, we must be competent, and the systems have to be compliant in accordance with standards. And they're the kind of things that we're going to be discussing. So key issues: safety, compliance, and competence. And this means that all of us, it doesn't matter whether we're a design engineer, whether we're an installation contractor, a commissioning engineer, or a maintenance staff, we need to have the knowledge, we need to have the skills to apply that knowledge, and we definitely need to have the attitude. And these are three key issues. And on the attitude element, the human factor element, I've extracted here, look, safety behaviour as one of the directives, one of the regulatory bodies, and this is directly out of the CASA, Australian CASA regulatory group, and EASA and EUROCONTROL in Europe, where we come from, have exactly the same statements. And it's very, very important to have and understand that we need to have the attitude to understand the fact that to design correctly, to install correctly, to commission the systems correctly, and have acceptance criteria, and including on the maintenance side, particularly for the guys on the maintenance side, because we'll know that it's not just sitting in the sunshine out on the airfield in a lovely warm day doing some work. It's cold, it's wet, etc. It's in the night, you're tired. All those elements kick in when it comes to attitude. So one of the elements that we had not discussed last week or had the time to discuss last week is, how do we achieve competence? Then we need to have familiarization training in one form or another. And we discussed last week the criteria associated with the training phases: basic training, qualification, continuation, and development training. And this is guidelines from ICAO. However, before we proceed on that process, we need to do a training needs analysis. And we, in the TMS Training Solutions, are involved with that and can offer anybody, any airport around the world, a visit to undertake a training needs analysis. However, we follow what is called the ADDI model. And the ADDI model is, as it says here, we analyze, we design, we develop, we implement, and we evaluate. So it's back to that CBT, competency-based training and assessment, CBTA. So what are we going to do in Webinar 2 and Webinar 3? In Webinar 2, we, as I showed you for those who attended last week, we have split the webinar series of training into 3 steps. And the first step 1 is working safely airside. Now, when we work airside, you know very well, you have to drive a vehicle, so we have to have driving permits. We need to communicate with air traffic control to get approvals to move from one place to another around the maneuvering area, the movement area of the airfield. And so there's a whole range of elements, the awareness of where we are, runway, taxiway, access, it has to be requested and approved. So working safely airside is a multitude. Now there's 2 videos. Now I'm not going to show the videos during this webinar. We just don't have time, in an hour. So we will have these videos. Both of those are available as a link from our website after the webinar. What we'll do though is to go into the Airfield Ground Lighting. Some people, it's formerly known as Aeronautical Ground Lighting. Some people call it Airport Ground Lighting, but it's AGL or AFL if you're in Asia Pacific. We're going to deal with lesson 1, lesson 2, and lesson 3, and introduce ourselves to lesson 4 this week. Then lesson 4, 5, 6, and step 3 will be during next week's webinar in webinar 3. So where do we fit? Where does AGL fit in the wider aviation airport operational needs? And I quite often get asked that question. We fit
I hope you can hear Keith better than I can at the moment. I seem to have lost him. Let me just, I'm not sure if anybody else can hear Keith. Let me just check. Right. We've apparently lost Keith. I've just had a communication here. We'll try and get Keith back online. Felicity, if you can just call Keith, we'll try and get him to reboot his computer. I guess that's probably one of the reasons why these things are not as efficient as they might be, and why aviation will probably continue, because you don't really know when these things are happening. And also, I think caused by the sheer volume of users in these times, we can have a situation where the situations will freeze just because of sheer overload. Because I know a number of organisations are trying to use Zoom as a means of communication with their friends and colleagues. So in preparing for today's call, I did some research and had a look and see what was going on around the world, and I looked up the FAA. Every organisation associated, every regulator, and every organisation associated with our industries, very active at the moment, trying to promote safety as we try and restart operations. In particular, the FAA have sent out a notification saying that they're actually going to carry on their Part 139 testing inspections of airfields, so the inspectors will be carrying on throughout this process. It's not like in the UK where MOT tests have been suspended. We've also got EASA has published documents, and I've got a document here from ICAO where they're stating that they are ICAO has ICAO has put out a document stating that they will be publishing that they are encouraging the world's governments to allow key workers to continue to be allowed to travel because of their safety critical nature of their work and the need for them to maintain the airworthiness of and operations of both airplanes and the airports themselves. Excuse me just a moment whilst I try and see if Keith is still there. We appear to have lost him completely. I would suggest if we can just, I don't know if we've managed to get Keith online yet. I'll just, if we can unmute and just update. Have you been able to speak to Keith? Is he still, has he lost his line altogether?
He's just logging back in.
Right, so Keith will be back with us in just a moment.
Shortly.
Yes, as I said, apologies for this technical interruption. ICAO are putting out a joint call with the shipping authorities to allow key workers to travel freely throughout this difficult period, and because of the kind of quarantine restrictions that have been put in place by governments, make it virtually impossible for for such people to operate if they have to spend 2 weeks in isolation when they arrive at any destination and then when they return to their originating destination. We were hearing from a pilot just before today's call, in order to return a plane from one location to another, it takes over a month because of the quarantine requirements at both sides. So I'm just monitoring Keith. He's not yet in sight, but we will be back with you shortly. So as I said, Keith is going to be talking today about, he's talking to you about the working safely on the airfield. He's going to be going through the standards relating to airfield lighting, the principles and of design and the layouts concerning airfields, and also power supply systems and the circuits themselves, with a particular emphasis on safety. Next week, the plan is to discuss remote control systems. We'll be talking about the operational needs and technology changes as we get into the world of collaborative decision-making, CDM, which as you know is coming fast, although I don't believe the authorities governing us have really understood or sort of finding it very difficult, should I say, to cope with the very, very great demands of trying to coordinate so many nation states and all of the technologies covering from airfields to air traffic control to airport operations, and then all the third parties that are part of the supply chain for the process. We'll be talking then particularly in terms of technology advances and how it relates to you guys involved in the world of visual aids and airfield lighting in particular. And of course the implications for electrical safety. As I said last week, there have been incidents where just as recently as the last year, where people have working on airfields have actually lost their lives because of the, in particular the nature of the series circuit, the uncompromising nature of the series circuit. So I don't know, Felicity, have you heard? Is Keith still trying to get on?
He's still trying to get on. Yes. Yeah.
He's not waiting for me to try and link on to the to let him in or anything like that, I hope.
No, just waiting for his internet.
Right. So yes. So we have a local internet problem. We're actually, Keith is working from his home because of the COVID situation, obviously, and the need to protect others in his household. Being a spring chicken himself, he's quite safe, but unfortunately, it can't be said for everybody in the home. I'm actually working out of the office, as you can see, I think, and Felicity is working from her home. So I don't know how many. I know a lot of you are back at work. We have been visiting airfields in the UK, and we're very, very, very aware that there are a number of very much, well, completely restricted operations. Essentially, we're just looking at cargo traffic only. So hence, I think the 85% of traffic that reduction is virtually all passenger traffic, and the 15% represents cargo, which is still running pretty much as at normal levels, fueling the supply chains of the various organisations to feed us, provide PPE to the hospitals and to the the people that are necessarily working in this time. Well, we still don't see any Keith here. I'm watching keenly on my screen. I think he must have just an internet outage or something. Does he have any internet at all, do you know, Felicity?
He's just rebooted it, so hopefully it'll be up and running shortly.
Okay. Well, so apologies for that. Do bear with me. Bear with us. One of the things I know Keith is going to be talking about is very much in terms of the next development and training of the next generation of aviation professionals. As Keith said last week, ICAO has published a comprehensive document describing, which first of all does a needs assessment on the current environment and identified that we have something of a skill shortage in the visual aids world, because the training is very much for the day, for what you have in front of you now. And as the CDM environment comes upon us and the other technological advances supporting the aviation industry, there will be a need for us to develop our skills, knowledge and understanding to work with these new technologies in these new ways. So we'll be putting together a program of an audit for airports to be able to analyze their current skills, knowledge and understanding, and identify if there are any gaps at all that need to be bridged by training. And that's where we're focusing our efforts in the next coming months. So Keith will be working on that as a generic document and offering his services to individual airports to conduct those audits. Also, following these 3 planned webinars, we've had some requests to look into other areas, and because of perhaps a lack of knowledge or understanding, or just a need for general training and a refresher. And in particular, I know Tony Smith is on this call. Tony, known to many of you as the inventor of the PAPI, Precision Approach Path Indicator. Tony has offered to do a lecture for us all, explaining the development of the PAPI, how it works, and also covering important areas in relation to how to cite a PAPI in relation to your ILS system. And I think addressing some of the technical issues and challenges, because I believe there may be some gaps in some of the documentation that's available in this particular area. And Tony is clearly an expert and very knowledgeable on this subject. So we will be conducting a webinar specifically covering the areas of PAPIs, how they've been developed, how they should be used, how they should be cited. And in conjunction with Keith, we'll be looking at maintenance, and from our part, we'll be looking at measurement, because as we've said throughout this process, you can't manage what you don't measure. So measurement is key, both from a commissioning standpoint when installing new PAPIs, but also then on an ongoing basis, an airport needs to manage the operation of its PAPIs to make sure they continue to be compliant. And we're talking not just the leveling of the PAPI currently performed with a clinometer, but also measuring the photometric output, because they need to be giving the visual cues in low visibility conditions. So there are regulations governing their light output, both the red and the white, and of course the signal colors that they're supposed to emit. So we'll be talking about how you perform a photometric check, as well as a check to measure that the setting angle is correct as designed, and also so that the transition is within the prescribed range for an AGL PAPI. So Keith, Tony Smith and Keith will be joining me for a lecture on that area. We're also planning other lectures to cover the topics such as the measurement of aprons and stands. Many of you will have probably enjoyed the mainstream webinars held over the past 2 or 3 weeks. In fact, I think it's an ongoing program, and thoroughly recommend as a webinar to you. I think they're doing a cooperative webinar with some of our airfield lighting partners next week. So I'm sure if you Google the mainstream webinar, there's a very interesting and educational program going on there. So we'll be talking about the measurement of aprons and stands. And then finally, we're also planning a webinar concerning sign measurement. So signs are a particular challenge, as many of you will know, we have developed a some PAPI and sign testing equipment, and in our development of this equipment, we've identified, in particular in relation to signs, a lot of let's say shortfalls. So again, without the ability to measure the sign output, both in terms of the intensity and the color, it is very difficult to maintain them to the required, to a compliant level. And so we'll be conducting a webinar that will explain what the requirements are for signs and how you can measure them and maintain them to a compliant level. So that's all coming up in the very near future. We'll be putting details on our TMS Training Solutions website. We've also put on resources from last week's and this week's webinar to provide you information and videos and links to relevant websites for the content provided within our webinar. So we've got some videos, some instructional videos, and we've got some links to the EUROCONTROL, EASA, and we'll be putting a link up to ACI and some other documents, some ICAO documents that will be very relevant to airfield lighting and visual aids generally, and to support the training that hopefully Keith will be providing in the very near future. Do we have any update from Keith, Felicity?
He's just logging on via a hotspot on his mobile phone because the internet's down completely. So he should be with us very shortly indeed.
So not even not even the internet is safe from COVID, as you can unfortunately see. I don't know.
It would appear not.
No. But anyway, so he's valiant there. I can only feel for him. I imagine he's panicking terribly, and I can see from we have 119 participants on this call, and I thank you for your patience because not one has dropped out during this unfortunate interlude. So I really appreciate your patience at this difficult time, as we say. So as we go around airports and airfields in particular, I see a number of you that are able, that are fortunate enough to be able to carry on working, have been performing airfield lighting maintenance, which is great. There's been it does represent a very unusual opportunity, and not that we would want it so, but you have been granted unparalleled access to your runways and taxiways, and I can see from LinkedIn and other resources that a number of you have been able to take very good advantage of this. You just need to unmute, Keith. I see Keith is back. Are you there, Keith?
Yeah.
Keith is.
Would you? Yes, please.
Anyway,
bring me back in, Robert.
Yes, you have to apologise. I've been singing songs for the last 10 minutes, so apologies for that, everybody. And I'll hand back over to Keith now.
Will you host it? Allow me in.
Oh, right. So I need to just allow Keith to share the screen again, but that should be a relatively straightforward thing to do. Right. So Keith, you can now put your screen on the webinar, and normal service will be resumed.
So are we back online, guys?
Yes, we are, Keith. You're good. Good to go.
Okay. I must apologise for that. That's the local network in my area just went down for everybody. Because I had my wife shouting to me, "The internet's not working," and I think the Virgin van is just down the road working on a box. So I'm now on. I've gone onto a hotspot through the phone system. So hopefully this will work okay. one of the aspects that where I think I got to this slide here, you know, where did we fit into the whole CNS, the communication, navigation, and surveillance system? And we were looking at this slide here associated with, we've got to have the correctly selected equipment and correctly installed and acceptance criteria with tools. And I'm sure Robert has been talking about various tools such as photometric tools and etc. And having an inspection program and all the schedules associated with an inspection program in place to ensure compliance. But when we really coming about us, the personnel, and I did hear through in the background that Robert was talking about Tony Smith, who is you know, the world's guru on PAPIs, and you know, but the personnel and the knowledge, the skill and the attitude of personnel is exceedingly important. The regulatory guidelines that have come up, and this is a regulatory guidelines that has been directed from ICAO and national authorities and regional authorities, and our regional authority in the ATS side, in the CNS for the communication, navigation and surveillance. EUROCONTROL has issued a new document this week, and edition 1.4, and in there they've referred to technical staff. Technical staff are competent and in insufficient numbers to provide adequate CNS and information services, and we should be we need to check that our competence is maintained and we have the correct number of staff to operate our airport. And if it's considered not to be appropriate, there should be a risk assessment, and if so, then refresher training, etc., should be undertaken. So it really is a subject which is of high importance when it comes to safety, compliance, and competence. So let's go forward quickly now to working safely airside. Now, we are not going to show these two videos. They are available for you online via our website. And as I said earlier, it covers a whole range associated with radio communication, driving, understanding what the signage is all about and where we can go and cannot go, etc. So with further ado, I'll just move on very quickly to the step 2 of our webinar, which is lesson 1, which is introduction to AGL standards, principles and layouts, etc. Now, what is very good, on the bottom to the left of your screen here, if you go onto the UK's CAA, Civil Aviation Authority website, www.caa.co.uk, they have a document available free of charge in soft copy online, Civil Aviation Publication 637. It's a handbook, really, really good. And I suggest you know, all of you, just download it, because there's a lot of good information in there about the whole element of working airside and AGL. We also have got a video. I'm not going to go through the video within this webinar, and certainly not now, we've been delayed, that it's a night approach to Dublin Airport in Ireland. And it's really good because it shows an approach, and it also shows us a taxiing. And it's quite an oldish film. And in Dublin, at the time the film was made, some of the taxiways were illuminated with AGL and others were not. So it gives the video, have a look at it and download it from our website and have a look at it, because it just shows the importance of having you know, illumination and visual aids. Going to the standards, Annex 14 is is our international guideline, and all our authorities adhere in one form or another to Annex 14. The centre one shows here, Annex 14 Volume 1. There is a Volume 2 for heliports. This is Volume 1 aerodromes. Volume 2 is for heliports. these documents they are supported by aerodrome design manuals, and I've just shown one here, part 5, which are electrical systems, whereby we also have the International Electrotechnical Commission. Interestingly, both ICAO have a visual aids working group, and the IEC have a Technical Committee 97 dedicated, both of those are dedicated to airfield ground lighting. Moving on to the standards. Here we have a standard associated with ICAO. Volume 1, as I said, Volume 1 is aerodromes, Volume 2 is the heliports, and I've just selected a few of the relevant design manuals from ICAO, which are appropriate for AGL. And part 4 is visual aids, part 5 electrical systems, part 6 is frangibility. As we all know, if we're going to put an AGL piece of equipment out in the field, then we want to be able to safeguard the aircraft should the aircraft land on it, if it's on a runway, or come off the runway and on a taxiway, or in the event of an incident. And so the frangibility element is really important, but it's not just mechanical frangibility, it's electrical frangibility as well. So that's really really a key aspect to consider. And then we have a services manual, a whole range of services manual. Part 9 is about maintenance practices. I have to say though, then really technology has overtaken that document. I mean, for example, it talks about doing maintenance on a calendar basis, etc., which is still valid in many airports. But of course, we have asset management tools and software tools available today. The ICAO so have this whole package. The IEC, on the other hand, are the technical provide the technical specifications, and I've just put 2 technical specifications here, which is all about safety on a constant current series circuit, which is AGL. 61821 and 62143 is all about safety, but there is a whole range of technical specifications from the IEC, which, for example, if you want a CCR, a constant regulator, there's a technical specification 61822 for the constant current regulator. One of the standards, and I mentioned, was for the heliports. This is hot off the press, newsflash really, because ICAO has just released the equivalent of an aerodrome design manual for heliports. And heliport manual is for the design and operations of offshore heliports. That's part 1. Part 2 will be issued for onshore heliports, and it will support Annex 14, Volume 2. So there it is, hot off the press, ICAO document 9261, 4th edition, 2020, available from ICAO. So let's have a look at airports. Every airport layout is different, every single one in the world. And therefore we give a level of complexity associated with the layouts on airports. So we have a basic, a simple, and a complex. And I think it's most of our airports, which are passenger carrying airports, then are either a simple one, having 1 runway, but more than 1 taxiway, or it's a complex airport where there are 2 or more runways and a whole range of taxiways, etc. We also have the reference code for an aerodrome, and the reference code is split into 2 elements. And at the bottom of this slide, we demonstrate if you have a code for E, for example, reference code, the element 1 is the numerical number, and element 2 is the alphabetical letter. So 4E is a requirement for a jumbo 747, where 4, I say, is the length, and E being the aircraft size. And this information comes from a chart in Annex 14 with codes 1 to 4 and A to F. F4 being the length of the runway being over 1,800 meters or over, which most of us are in today's day and age, where F being quite a large aircraft such as the Airbus, the largest Airbus vehicle. Categories of operation is another factor that we have an understanding, and these are based about operational status according to how far the pilot of an aircraft can see. Now, what I mean by the pilot of an aircraft can see, the pilot, when he or she is sat in the aircraft on the runway, on the ground, how far can he or she see the visual aids down the runway? That is runway visual range. And the directives associated with that is if you are a categorized runway, that means you're an instrument runway. There are lots of facilities. There are non-instrument runways, which do not fall into this categorization. But instrument runways fall into this categorization. And therefore, RVR of distances of 550 meters or greater, or the overall visibility of 800 meters, that's category 1. When the visibility drops below category 1, then it becomes a category 2 scenario. And when the visibility drops again below 300 meters, then it becomes a category 3A. Below 175 meters becomes category 3B. And then when it drops below 50 meters, it becomes a category 3C. Now, if you look at that, below 50 meters, that's not very far. So as far as visual aids are concerned, we're not interested, because you can't see visual aids if you're traveling at 150, 200 kilometers an hour, and you can only see 50 meters. So Cat 1, Cat 2, and Cat 3, A and B are relevant to AGL. But really, remember, understand, RVR is also part of the calculation for the instrument landing system as well. So we have to put a percentage of accuracy, efficiency into the ILS system, basically, and it's called IRVR, Instrument Runway Visual Range. So the system has a percentage of accuracy, a percentage of efficiency associated with the AGL. And you know, so not many people know this. And it can affect traffic density and how many aircraft that we can land on a runway at any time, as one of many other factors. Lots of discussions are going on in the world prior to the COVID associated, and trials associated with traffic density using existing infrastructure. But we have a whole set of training systems associated with being able to educate and share this knowledge. So I can't do it all in this webinar. We also, when we're looking at traffic density, we also designate our airport as either having been a light, medium, or heavy traffic density. And it's pretty clear that traffic density, the more aircraft that you have on the ground, dependent upon the visibility conditions, of course, that's another part of the equation, then we need to have additional support. Maybe the follow-me vehicle, for example, for an aircraft leaving the runway and using a taxiway network to get to the apron, and vice versa. However, we can use AGL, the follow the green concept, as many people will have heard. So you know, traffic density does affect what systems in AGL we need to install on the taxiway network, for example. Moving on then, let's move on, and I apologize for moving on quite quickly here, you know, because of the problem I had with my internet. Let's have a look at power, AGL power, then we'll look at the lighting, and then we'll look at control. But when we're looking at AGL, there are 4 key issues that we do look at. That's the 4 C's of AGL. Configuration, that's the patterns, you know, the distances between lights, etc. The colour, as we all know, we have the greens and the reds and the yellows and the blues. So they identify what systems, and it gives a pilot some clear definition. Candela is the actual light output, or some people call it candela. So that's the level of light output from the light systems, together with the various intensities, because we have intensity settings, whether it's daytime, nighttime, poor visibility, high visibility. Then we have different intensity levels. So that's candela. And then we have to point the lights in the correct direction. And that's the coverage, the beam spread, and the orientation. So the 4 C's of AGL, pretty fundamental to us. And the picture at the bottom left-hand corner, I think, describes all 4 of those, all 4 of the 4 C's. Moving onwards to how do we look at AGL in terms of, well, we need AGL for landing on a runway, so they're runway-related lights. And we need lights on the taxiways to enable us to transit to and from the apron to the runway, etc. And so this is how we split our lighting. Interestingly, runway lighting, the intensity of runway lighting is higher than the intensity of taxiway lighting. Why? Speed of aircraft. Pilot reaction time. Very important. So runway-related lighting is always of a higher intensity than taxiway-related lighting. This is the video associated with the approach. Now, I was going to show it, but a part of it, but not now. So I'm just going to go straight on. It's online for you, and I'm suggesting that you have a look at it in slow time. It's really a good video which shows both approach and taxiway lighting. Now, many people say, well, what lighting systems do we need if for the different categories of operation, Cat 1, Cat 2, Cat 3? Here's a nice little chart. Now, bear in mind this presentation is downloadable for you. It's been recorded, it's downloadable for you from the website afterwards. And you will see here that there's a whole list of systems on the left side of this chart about the lighting systems, and the columns associated with Category 1, Category 2, and Category 3. I'll zero in on, say, the PAPI, the Precision Approach Path Indicator. Really, really important. The PAPI is really, I would say, AGL's direct influence on flight safety, because it's really important to have those visual cues for the pilot doing the approach and landing. And if we're at Category 1, we can see we have the visibility, our VR visibility is 550 meters or greater. That means the PAPIs will be able to be seen clearly by the pilot when he is already getting pretty close to the threshold. But when we go to Category 2 and Category 3, where the visibility have dropped below 550 meters, then the PAPIs are not going to be too much use. And in Category 3, we might as well just switch them off, because if you can only see a little over 50 meters and you're traveling at 200 kilometers an hour, then I'm afraid, you know, it's going to be instrument landing only. So this is the nice little chart to explain which systems need to be installed for category 1. We have a whole range of systems for Cat 1 that we install, and then we add systems as the visibility comes down. So we could be a category 1 airfield, we could be a category 2, or we could be a category 3. Or it could be a mixture, depending on which direction of runway we're using. Now let's go on to the actual approach and the runway lights. There is a pattern associated with approach lights. This I'm showing here is a pattern which is ICAO called the distance coded. And it is a category 1 approach pattern, distance coded, commonly called the Calvert after the guy called Ted Calvert. Interestingly, Robert mentioned Tony Smith. Tony Smith worked with Ted Calvert, you know, a lot of years ago. But it's sometimes called centerline 5 bar, and it's also referred to as a type A in the aerodrome design manuals of ICAO. So it's like an arrowhead, as you will see from those diagrams. Also, and alongside here, I've took an extract out of the MOS 139 standard in Australia, and this diagram is just demonstrate not just the Calvert system at the top, but also the American-derived Barrette system and Barrette centerline system. You will see they are fundamentally different. The Calvert, or the distance coded, have 5 crossbars and a centerline set of lights, whereby the Barrette system has a centerline set of lights, more of them, but a crossbar. But that crossbar is at 300 meters, exactly at the same position as the second crossbar in a Calvert system. So there is commonality. And here is a diagram where, when we upgrade from Cat 1 to Cat 2 and Cat 3, in Cat 2 and 3, we have in fact added additional lights. And these are red lights. In this format, with a Calvert system, they're called supplementary approach lights. In this system, with a Barrette system, they're called side row Barrettes. Same thing, same job. But with a Barrette system, we also add a 150 meter crossbar. Moving on to the Barrette system of an approach, ICAO recommend, and it is only a recommend, that if conditions dictate, you shall add a sequence flashing approach system. Now, the sequence flashing approach system is a set of strobe lights called the running rabbit, and they start at the furthest away set of lights away from the threshold. And for category 2 operations and category 3, they are installed in line with all the other steady burning lights as far as the 300 meter crossbar. For category 1, if you add a strobe system, then they go all the way down to the threshold. So there is some differences. But ICAO say if you have a Barrette system, approach system, it's recommended if conditions dictate. Unfortunately, they don't tell us what that condition is. With a Calvert system, there is no requirement for a strobe system, according to ICAO. Moving on, threshold lights, green in colour, back to our 4 Cs. They shall be installed across the start of the usable part of the runway, within 3 meters of the start of that usable part of the runway, which is the threshold. And they're spaced at distances apart no greater than 3 meters apart between the runway edges. Here's a diagram associated with some taxiway related systems. And what I've particularly done with this one is to choose an extract on this diagram, just to show you a rapid exit and an exit other than a rapid exit, together with a stop bar, which is the runway incursion protection equipment from AGL, the fundamental ones, where we have red lights across the runway holding position, and we warn the pilot that he's coming to a runway holding position by having runway guard lights, which are commonly known as wigwags. On taxiways, though, we illuminate the taxiways. We have taxiway edge lights, which are blue, but when we go to category 2 and category 3, we are using the lights as part of surface movement guidance, then we add runway taxiway centerline lights, and they're green in color. And likewise, if we're going to exit the runway, these taxiway lights are also installed in the runway, and they're commonly called lead-off lights, and they are green, amber, green, amber, green, amber, green, amber, until they get to the location of a runway holding position, a line in line with the runway holding position, which is often the ILS, MLS critical area. That means nothing can go inside that area because it would affect the performance of the ILS system. But big subject this, and in our training courses, then we spend a lot of time talking about these. I've also highlighted this rapid exit because rapid exit lead-off lights also have some identification lights, and they are yellow lights spaced at 100-meter intervals in a 3-2-1 configuration, as shown here. Very interestingly, though, from an AGL operational viewpoint, if one of those 6 lights go out, all of them should switch off. So how you do that? Well, we can discuss that in training courses. No time today. Runway holding position. What I'm doing here, I've particularly selected this photograph to show you because this shows a runway holding position with stop bar lights across, with some elevated stop bar lights either side, which is an option, and places like where there's snow, then they're very important to have. It shows the wigwags, those runway guard lights, but it also shows a runway with some puppies and some guidance signs and some taxiway edge lights. Now, this is from a training facility in Indonesia. Now, they have 2 of these in Indonesia. And what I would ask you around the world, do you have a training facility like that? That you can do training courses where you can gain the knowledge, but how can you apply that knowledge into the skill if you don't have a training facility to be able to practice it on? Because how often can you get onto your your runway and your facilities because of traffic density? So this is really an important, and this is why I've included this. So Indonesia have 2 of these training facilities. Moving on to guidance signs associated with the runway, guidance signs associated with the taxiway, and in principle, they are mandatory guidance signs, which are red with white lettering, but also, we also show the advisory ones, the information signs, and here we have on the end of such guidance signs, then we have location signs. Now, these will be installed in and around the runway holding position. Then we have the information signs, which can be a location or a destination sign, or as we sometimes call it, I'll say a direction sign. And here is a complete combination. Now, very important, really, I think one of the most complicated things for a design engineer is to identify which guidance signs are needed in a complex aerodrome, because even when you've designed, you've installed and you start to operate the airport, then the aviation people would say, I was a bit confused at that junction, so we have to do a lot of changes. So these are not always fixed and firm, even when you do a design, a greenfield, or even a brownfield upgrade. Guidance signs create a lot of a discussion. And also very important, though, with guidance signs, when you look at guidance signs, you need to clearly see all the legends. And how many times have you looked on an airport and you see the legend, but you've got shaded dark areas around the outside? Very important for the compliance of guidance signs that they meet the photometric output. This one is showing the PAPI. Now the PAPI is as I said earlier, is probably the AGL's primary interface into flight safety. And I've extracted two documents, two pictures, diagrams on this slide. One from the standards in Australia, MOS 139, and details from the standards in Canada, from Transport Canada, just to show that it's not just you know, an international ICAO directive. Each of our national standards agencies, in the form of CAAs or whatever we want to call them, then issue their sometimes minor variations to the standard. And so the PAPI is, if you want more details on the PAPIs, then we do a dedicated PAPI course, and already Robert Shapton mentioned Tony Smith, who's the world's guru on PAPIs, who provides us a lot of advice. And thanks, Tony. Thank you very much for that. Moving forward, just some pictures. This is out of that a handbook from the United Kingdom's CAA, and some extract of a runway with a taxiway network. And I said all layouts are different, so these are just purely diagrams I selected to show that what we're talking about. And again, this is out of some design documents, and this one, it shows not just the runway, but it also shows a taxiway network with the rapid exit and the exit other than a rapid exit, and the color of the lights, etc. So we have a whole range of these in our training courses to discuss. And in fact, when we do a design course, we actually develop one. We do a dummy airport, basically, and you design it for yourself. So let's move on to the power supply technology associated with AGL. We split AGL into three simple blocks: power, control, lighting. And when we go to the power side, then this is step 2, lesson 2. Where does the power come from? Well, it comes from the ring main, you know, which comes from the power station. Sometimes some airports are very lucky, so they can get 2 separate independent electricity power suppliers to provide the airport. So if you lose one complete power station, you've still got a supply from the other, or from the national network. We also have the standby and the standby power for each of our substations or vaults, whatever you want to call them. There will be a diesel genset, and many times in the modern era, it's supported by an uninterruptible power supply, a UPS. And then within the substation, we have to distribute that power to the CCRs. So we have distribution equipment, which is of a lower voltage. We normally 11 kV coming into the power station, and then it's transformed down to usable voltages of 3-phase or single phase. But those distribution boards, we need to have safe working involved. So they should have lock-off or isolation equipment associated with the distribution equipment. The diesel genset, well, there's mechanical engineering here because it's a big diesel engine. So we have to say to ourselves, wow, you know, we need to, somebody needs to maintain that as well. And we also have criteria on how long it takes to get the standby power on if the main power fails. And that we've given some criteria of something like 15 seconds for a category 1 airfield and 1 second only for a category 2 and 3 airfield. And that's why the uninterruptible power supply, the UPSs, have really come into the fore in more recent years. Onwards to the power unit itself of the AGL,
Oh dear, we appear to have lost Keith again. I'm not quite sure what's happened here, but we're having a very unfortunate day with his local power supply. Perhaps we need an uninterruptible internet supply for Keith and his operations. Certainly seems to be letting us down. What I'd like to suggest is, as this is a series, and we've been going for just 1 hour now, I'd like to kind of wrap up because I don't want to keep you for any longer. I think the message for us all in our airports is to prepare for operations again. Andrew Badham from the UK CAA sent me a message reminding us all about the EASA preparatory document 2000. Now, if I look at the reference just sent to me, we're looking at a document called EASA SIB 2007-07-1. This was something, and thank you for reminding me, Andrew. It was put on we put it on our webinar 1 resources last week. So please refer to that because it's an EASA document and it refers to all the preparatory steps that should be taken for the resumption of operations. So that's on our webinar 1 resources on the tmstrainingsolutions.com website. Preparation is key. It requires risk management, risk assessment, putting together risk mitigation plans, and then performing all the necessary planned preventative maintenance necessary for your visual aids. So, are the lights serviceable per ICAO? Are the airfield lights at risk of becoming FODs? So when did you last torque check them? For the PAPIs, obviously, checking them with the clinometer, relamping them, checking the signs are all operational and clean. One of the key things we've seen with the airfield, one of the key areas we've seen with the airfield lighting, with the testing we've been doing recently at airports, is that signs very often are quite significantly obscured by grass and plants growing in front of them. So you need to get your gardeners out and get cutting and hopefully avoid knocking them down, which we see too often as well. And finally, also making sure the apron lighting is performing according to standard. So next week, Keith will resume where he left off from this week. We'll make sure we do have a sound internet supply. He will be moving on from the power supply system and AGL circuit to remote control systems, the operational needs and technology changes, in particular relating to automatic routing, guidance and control. We'll be looking at the technology advances, particularly in relation to CDM and electrical safety. which of course applies to old technology as it applies to new technology. It's just getting more complicated. So I see there are a number of questions, but as we've run over, we will post answer to those on the web for you all to share. Those should be up and running by tomorrow at the latest, along with the resources and the videos that Keith mentioned earlier, in particular relating to operating safely on the airfield, and also that very good video of the Dublin approach and landing. So I'd like to thank you all very much for participating this week, and wish you a safe and happy next week, and I hope to see you again next week. Thank you very much. Goodbye.